Hi, everybody. So talk is about this shift to heterogeneous hardware and kind of positioning Presto as an awesome way to prepare for this kind of complex environment we're entering into. Just to set the stage, though, what do we mean by this? And this is a quick explanation of the chart. If you follow the red, that's YouTube data growth year over year up to 2016. And the blue is spec int. You can see for most of the period, spec int and data growth were in lockstep. But as you move towards the right, you can see spec int starting to fall off. That means data is growing faster than compute performance. And that leaves a backlog that is a challenge. It's even more so a challenge when you start to think about performance per watt. And this is what's shifted the world to start to introduce accelerators. And so what do we mean by an accelerator? Well, I think the absolute best concrete example is Amazon's Redshift and their new Aqua accelerator. So I tried to position this here, but this accelerator is purpose-built query accelerators. Yep.
David, sorry to interrupt, but we can't see what you're speaking about if you want to share your screen.
Oh, I thought I did. So here was what I was talking about with the data growth exceeding the performance of the CPU. Here's a concrete example of the accelerators, and specifically Aqua. What I think you should internalize, though, is more and more services running on the cloud are going to be taking advantage of these accelerators. And it's really, really crucial that we have the right abstractions. So what I wanted to just point out, and these are some examples, but for those of you who haven't heard, CXL is a new way to add additional compute accelerators and memories onto the host server bus. And one of the exciting parts about that is it'll allow you to actually add memory that will be effectively far memory. Manoj Whitaker gave some insight into activities that he and the team at Meta are working on what he open source project that provides a caching abstraction. And an interesting aspect of that is where it fits in with say, the Velox library and its use inside of the next gen Presto C++ worker. So that's kind of some high level insight into how accelerators are starting to emerge into the infrastructure. But what I wanted to kind of set the tone on is where did this really fit in the context of the data lake? So on the left-hand side, I just listed out real quick a few proprietary closed source query engines, quite popular, awesome. But what if there was an open source set of abstractions that were libraries that you could use and leverage across multiple query engines, and they hid the accelerators and the memories, et cetera, that are coming online. So I just wanted to kind of position this in the context of not only Presto, but some of the other query engines that Meta has been talking about publicly over the last 18 months or so. And so just to point out this library, the Velox library, and then Cachelib, these two things together, when plugged into, say, a stream processing engine like Xstream or a query engine like Presto, provide the ingredients to allow for these abstractions to hide the complexity of running on the CPU, general purpose CPU at one point, and then taking advantage of, say, a GPU at another point in the query stages. So that's kind of hopefully providing some clarity on where this is positioned. And then just to give you an idea more concretely, on the left-hand side is a very, very simple depiction of a smartphone type app interacting with that top serving bubble. And all of the clickstream data and any transactions and observability data is all being flowed into the ingest processing plane to do ETL or whatever else is needed to then flow into storage, the data lake. And ultimately, that's going to be processed and transformed into features that end up in the training, and then the trained models get pushed back out to the serving environment. So that's just a simple example. It represents massive, massive amounts of data. And on the right-hand side is just kind of a stack, but the point is this stack is bespoke, and it doesn't have the kinds of abstractions that are necessary to introduce new hardwares and be able to allow for the top components of the stack to take advantage of that new hardware. So just to then show these introduction of the abstractions with Velox and Cachelib as the example, if you think of Aqua as providing a disaggregated cache and a computational push down mechanism, what if that was generalized and open sourced in the context of, say, Velox and Cachelib, and then integrated into Presto as the example? That really hides the complexity from all of the up the stack code and allows for these new innovative accelerators to provide massive speed up, much better efficiency, and much better performance per watt. And this is as evidenced by Aqua and the work that Meta's been talking about this year, and as well as with all the activity around CXL, et cetera. This is really important staging of these abstractions. So the other big thing about change is we need benchmarks, the industry standard benchmarks, to reflect these changes. So I'm just going to use TPC-AI as the example here. On the left-hand side, the current generation and specification for TPC-AI uses a star schema. And what we're finding and realizing is the data set sizes especially for the pre-processing of data for training really needs to have a different model, to have flat tables and take into account complex data types. And this is a really critical gap, especially in getting ready for taking advantage of all of this heterogeneous hardware. And really that's the crux of what I wanted to talk about today, and is this need for benchmarks, this industry shift to heterogeneous hardware, and how we can take advantage of abstractions like Velox and Cachelib to prepare and exploit the awesome hardware that's going to be coming online. And so just to kind of close this out, is the market is definitely shifting. If we want to continue to have a performance per watt curve that continues to increase in line with our data growth, we have to make this shift, and the shift is already well underway. And you can look around in all of the large cloud hardware software operators, and they're all preparing for this. And it's crucial to have the right software abstractions, and there's no better place to look than SQL and a query engine like Presto, and the work that's underway to introduce Velox into the Presto worker. So it's really, really exciting. And then I'll just leave everyone today with a call to action to really think about what the benchmarks need to reflect to go beyond the star schema and really look at data sizes that are much, much larger and can't afford, multiple joins to provide, to be able to leverage the normalized model that's inherent in the star schema. And so we really need to come together as a community to drive this change to reflect flat tables, et cetera. So with that, that's pretty much my talk for today. Thanks, everybody.